feature of our streams in northeastern Minnesota is they all have waterfalls. Just the way the geology made this place when the glaciers came through a long, long time ago, and some volcanic activity a long, long time ago. Most of you have probably been to Gooseberry Falls State Park, and this is the Pigeon River up on the border with Canada, which you can walk right up there and take this photo if you'd like. But almost every stream between Duluth and Canada, including the Lester River here in town, has a barrier. So with the trout and salmon that live in Lake Superior, they can only migrate upstream on average between all the streams between here and Canada. The distance between the lake and the waterfall is a half a mile. So there's really not a lot of habitat for juvenile trout and salmon to live before they end up going out to the lake to grow up as adults. So we're really confined in the area that the juveniles need to grow up. The other really important thing to point out is because of our watersheds being bedrock with basically clay overlying it, they're not very impervious to things going down, and they're not very impervious to things coming up. And streams are dependent on groundwater to flow. And a good way to go find springs and seeps and sources of groundwater is to do a little hiking in the winter, and this is the middle of the winter, but groundwater comes out of the ground at about 50 degrees Fahrenheit. And since we have very little groundwater in northeastern Minnesota, wherever we find sources of groundwater, it's very important to protect those sources. So one of the activities we do as biologists, which saves us a lot of time and effort because we can't hike all winter, we put out about 100 temperature loggers in area streams every year, and we've done that for quite a while. So these are temperature loggers that are basically the size of your finger. This is the old model, this is the new model. But we stick them in a metal pipe and wire it to a tree, and we'll just wrap some wire around a rod, a root essentially, and we can go out and kind of start to narrow down our search on where these springs and cold water seeps are located, so we would know where to protect them. So this is, again, this presentation is a little dated. This was a map I made back in 2006, but as of 2006, we had 706 locations on 101 streams in the Duluth area. Duluth is here, and this would be Thunder Bay, or this is probably the county line there. But so every year we've got about 50 locations that we monitor annually, so we can monitor big picture stuff like climate change. But then we've got since we put out about 100 temperature loggers, we've got about 50 other locations that we just go and monitor out of curiosity and figure out if they're cold water tributaries or if they're just warm water streams. Because we're trout guys, so we want to protect the cold water resources. And we monitor these locations between a specified time period, so we can compare streams between locations and among years. And the June 1st to September 30th time period is one that incorporates basically summer in Duluth. And that's when water temperatures would get hot and approach the lethal limit for cold water species like trout. This is a surprising graph, and hopefully it tells you about our streams. On the x-axis you have dates, so you've got April through October, and temperature in degrees C, but you can, if you can't do the conversion in your head, it doesn't matter. The point is just to look at this graph. And if you say you went down to Whitewater State Park in southeastern Minnesota, which is a pretty popular park, on an average summer day, you'd expect the air temperatures, say, to be 85 or something, and then the stream temperatures to be down in, say, 65. But we don't have much groundwater. So if you're driving between, say, here and Grand Marais, and you've got to put your air conditioning on your car or roll down your windows because you're hot, the trout are too. Which basically shows that the temperatures in the streams very, very closely parallel the temperatures in the air. And this is just another way to look at it. Again, don't worry about the units on the y-axis, or the x-axis, but this is basically at our office, which is at the mouth of the French River. This is our temperature loggers record water temperature every hour of every day between June 1st and September 30th, and this is every single data point between 96 and 2006. And the point is, you'll see at 25C, which is roughly about 77 degrees, it turns into about 23C, which is about 74 degrees. So on average, the stream temperatures are only about 3 or 4 degrees cooler than the air temperatures. So just because we have very little groundwater because of how the geology, the hand geology left us, it's very important to protect that groundwater. Again, this is on the x-axis. You've got dates, so June through September, and degrees C on the y-axis. And don't. I give this at some angler user groups, and anglers very unhappily raise their hand and say they don't understand degree C, and I say, well, that's not the point of the figure. These are brook trout, and this is, again, at our office. The French River is one of our very intensively studied streams. Or, excuse me, these are steelhead. So this is the range below growth, so basically cold water, the range that they preferably grow in, the water temperature range. When water gets a little too warm, their stressful range, and then what water temperatures kill them. And this is from 2003 and through 2006, and these are the data throughout the year. And the point of this figure is just to show that it doesn't really matter what year it is. We're very much on the thermal threshold for trout and salmon, which I think Nadine wrote in the summary that you're going to get. So we're basically on the tipping point. So if we get something like climate change that really impacts our groundwater and our water temperatures, it could mean the end of trout and salmon on the Minnesota Shore Lakes period. So basically every single year water temperatures get up in this stressful range. And the French River is kind of seen as one of the better trout streams. So you can imagine on some of the streams that we might consider marginal trout streams, they're going to have temperatures up in the lethal range every year. This is the same figure. They're just mean, so you don't have all the crazy noise. But the point, again, is just between about mid-June and say late August, the French River and most rivers on the Minnesota shore, sometime during the day, probably mid to late afternoon, they will have water temperatures that enter the stressful range for fish. This is another interesting thing that, as teachers, I just threw this slide in from a different presentation, but alkalinity is it's kind of a crude way to measure productivity. And you can go take a water sample in whatever stream is closest to your classroom if you guys are out on a field trip, and run an alkalinity test, which is probably in your basic hot kit for your water chem. And this just shows the difference between northeastern Minnesota and southeastern Minnesota, and just how nature left us. The average productivity or total alkalinity limit is about 25 parts per million in northeastern Minnesota trout streams. And southeastern Minnesota, the average is about 236. And so you can just see it's just orders of magnitude, again, different between if you jump into Amity Creek or Lester Creek or whatever in the Duluth area and you start picking up rocks, which is something that I find interesting, but people probably don't. You'll turn them over, and in the Duluth area, you might have to turn over 10 or 15 different rocks to find one macroinvertebrate. And the stream is not productive enough to sustain a lot of biomass of macroinvertebrates. But if you go down to southeastern Minnesota, this is a picture from down there, you can see the periphyte and algae and probably some duckweed there. And you turn over those rocks, and they'll just be crawling, and just life all over the place. It's a good, I thought, a good quick lesson that you could show kids on how productive or unproductive the streams are based on our geology.